So dear students, so in last two videos, so we talked of moving coil galvanometer, MCG, MCG. So very important topic. Then we talked of how to convert MCG. So MCG is an ammeter. How to convert moving coil galvanometer into an ammeter. So it is also very important topic. Then we also have studied about how to convert moving coil galvanometer into an voltmeter. What meter? Voltmeter. Voltmeter ಬೇರೆ voltmeter ಬೇರೆ. This is voltmeter, which measures the potential difference. Voltmeter. So these things we have studied. In moving coil galvanometer, so we have derived an equation. We have derived an equation for angular deflection. So the angular deflection phi was equal to, what was the equation? N into A into B divided by K into I. So this was the equation for angular deflection of a moving coil galvanometer. And the moving coil galvanometer, so there was a scale. So there was scale ittu. So there was a pointer. So the deflection in the pointer, the angular deflection, so it is 0. So I say it is 20. So this angular deflection, that is phi, that will be called NAB by K into I. So N is the number of turns of the coil, A is the area of the cross section of the coil, B is the strength of the radial magnetic field, uniform radial magnetic field, K is called a torsional constant, and I is the current. So from that we have come to conclusion that phi is proportional to I. And by measuring the angular deflection phi, we can directly measure the current or potential difference. Then in conversion of moving coil to ammeter, so we have to connect a small parallel resistance, resistance which is very small in parallel to the moving coil galvanometer. So that resistance we call it as RS, that we call it as shunt resistance. ಏನಂತ ಕರಿತೀವಿ ಅದಕ್ಕೆ? shunt, STSHUNT, shunt resistance. Shunting ಅಂದರೆ connecting in parallel ಅಂತಲೇ ಅರ್ಥ. So shunt resistance, what are the value of shunt resistance? RS was equal to IG RG divided by I minus IG. So you should know this one. Also we have studied how to convert moving coil galvanometer into a voltmeter. How to convert a moving coil galvanometer into a voltmeter. So to convert a moving coil galvanometer into voltmeter, ಏನು ಮಾಡಬೇಕು? We should connect a very high resistance in series. That value of the high resistance R was equal to, so what was the value of R? That was equal to V by IG minus RG. So what is IG? Lateral IG ಅಂದ್ರೇನು? IG is current required for full scale deflection. RG is the resistance of the galvanometer, moving coil galvanometer. Here I is the range of the ammeter, that is 1-2 ampere ಮಾಡಬೇಕು, 10 ampere ಮಾಡಬೇಕು, that is the range. ಇಲ್ಲಿ V ಅಂದರೆ range of the voltmeter. So these equations you should remember. Then now we will talk of very important characters of the galvanometer and the conversion of galvanometer into ammeter and voltmeter. So we will talk of some important notes, very important. So you should remember those things. So note, so in notes ಅಲ್ಲಿ ಬರ್ದಿನ note ಅಂತ. So what is the first note? The first note is that for an ideal ammeter, ಒಂದು ಯಾವುದೊಂದು ಅಮ್ಮೀಟರ್ನ ಐಡಿಯಲ್ ಅಂತ ಕರಿಬೇಕು ಅಂದರೆ, ideal ammeter, nobody is ideal in universe. ಯಾರು ಐಡಿಯಲ್ ಸ್ಟೂಡೆಂಟ್ ಇದ್ದಾರಾ? ಇಸ್ ದೇರ್ ಎನಿಬಡಿ ಹೂ ಇಸ್ ವೆರಿ ಐಡಿಯಲ್ ಸ್ಟೂಡೆಂಟ್? ಇಲ್ಲ. ಎ ಗುಡ್ ಸ್ಟೂಡೆಂಟ್ ಇರ್ಬೋದು, ಬಟ್ ಐಡಿಯಲ್ ಸ್ಟೂಡೆಂಟ್ ಕೆನಾಟ್ ಬಿ ದೇರ್, ಯಾಕಂದ್ರೆ ವಿಲ್ ಮೇಕ್ ಸಮ್ ಮಿಸ್ಟೇಕ್. ಈಸ್ ದೇರ್ ಎನಿ ಐಡಿಯಲ್ ಪರ್ಸನ್? ನೋ. ಸೊ ದೇರ್ ಮೇ ಬಿ ಸಮ್ ಪೀಪಲ್ ಹೂ ಆರ್ ವೆರಿ ಮಚ್ ನಿಯರ್ ಟು ದ ಐಡಿಯಲ್ ಆಗೋ ಹತ್ರ ಇದ್ದಾರೆ, ಬಟ್ ನೋ ಬಡಿ ಇಸ್ ಪರ್ಫೆಕ್ಟ್ಲಿ ಐಡಿಯಲ್. ಜಸ್ಟ್ ಲೈಕ್ ಯಾರು ಶ್ರೀರಾಮಚಂದ್ರ ಎಂಥದ್ದು ಮರ್ಯಾದಾ ಪುರುಷೋತ್ತಮ ಅಂತಾರೆ, ಬಟ್ some people say is also not ideal, he had made many mistakes, ಹೌದಾನೆ? ಸೊ therefore nobody is ideal. So even God Sri Ramchandra was not perfectly ideal, because he was also a man, born as a man. ಸೊ ಹಾಗಾದರೆ ವಾಟ್ ಈಸ್ ಐಡಿಯಲ್ ಅಮೀಟರ್ ಅಂದರೆ ಏನು? ಐಡಿಯಲ್ ಅಮೀಟರ್ ಅಂದರೆ ವಾಟ್ ಈಸ್ ಐಡಿಯಲ್ ಅಮೀಟರ್? ಏನು ಅಮೀಟರ್ ಈ ಸೆಟ್ ಟು ಬಿ ಐಡಿಯಲ್. ಯಾವುದೇ ಒಂದು ಅಮೀಟರ್ನ ನೀನು ಒಂದು ಐಡಿಯಲ್ ಅಮೀಟರ್ ಕರಿಬೇಕು, ಹೌ ಟು ಕನ್ವರ್ಟ್ ಗ್ಯಾಲೋಮೀಟರ್ ಇಂಟು ಐಡಿಯಲ್ ಅಮೀಟರ್. ಸೊ ಒಂದು ಇದಿರುತ್ತೆ, ದೆರ್ ವಿಲ್ ಬಿ ಎ ಗ್ಯಾಲೋಮೀಟರ್. ಸೊ ಇದು ಇರುತ್ತೆ, ದಿಸ್ ದ ಸರ್ಕ್ಯೂಟ್ ಬರ್ಬೋದು. ಸೊ ದಿಸ್ ದ ಗ್ಯಾಲೋಮೀಟರ್. this is the resistance of the galvanometer Rg. So how to convert this galvanometer into an ammeter? By connecting a shunt resistance Rs in parallel. This is Rs. So ಇಲ್ಲಿ IG ಎಷ್ಟು ಕರೆಂಟ್ ಹೋಗುತ್ತೆ, ಐ ಮೀನ್ I ಮೈನಸ್ IG ಎಷ್ಟು, ಇಲ್ಲಿ IG ಎಷ್ಟು ಕರೆಂಟ್ ಇಲ್ಲಿ ಫ್ಲೋ ಆಗುತ್ತೆ. ದ ಮೇನ್ ಕರೆಂಟ್ ಈಸ್ I. So this is the ammeter. So for this ammeter to be ideal, ಅವನು ಹೇಳ್ತಾನೆ ಇಟ್ಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಶುಡ್ ಬಿ ಝೀರೋ. ಇಟ್ಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಶುಡ್ ಬಿ ಝೀರೋ. ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಾಗಬೇಕಾದ್ರದು ಝೀರೋ ಆದರೆ ದೆನ್ ದ ಅಮೀಟರ್ ಈಸ್ ಸೆಟ್ ಟು ಬಿ ಐಡಿಯಲ್. ಕೇಳ್ಬೋದು 1 ಮಾರ್ಕ್ಗೆ, ವಾಟ್ ಇಸ್ ಅನ್ ಐಡಿಯಲ್ ಅಮೀಟರ್? ಎನ್ ಅಮೀಟರ್ ಈಸ್ ಸೆಟ್ ಟು ಬಿ ಐಡಿಯಲ್ ಇಫ್ ಇಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಈಸ್ ಝೀರೋ. ಅಂದರೆ ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇದೆಯಲ್ಲ, ಇದು ಮತ್ತು ಇದು ಎರಡು ಝೀರೋ ಆಗಬೇಕು, ಬಟ್ ಅದಾಗಿ ಸಾಧ್ಯ ಇಲ್ಲ. ಸೊ ದೇರ್ ಫೋರ್ ನೋ ಅಮೀಟರ್ ಇಸ್ ಐಡಿಯಲ್. ಬಟ್ ಇವೆರಡು ವ್ಯಾಲ್ಯೂನ ಕಡಿಮೆ ಮಾಡ್ತಾ ಹೋಗ್ಬೋದು. ವಿ ಕ್ಯಾನ್ ಡಿಕ್ರೀಸ್ ದೆಮ್, we can make them to approach zero, but they cannot make zero. So therefore for ideal ammeter the resistance should be zero. ಯಾಕಂದರೆ always ammeter is connected in series. ಯಾವಾಗಲೂ ಅಮೀಟರ್ನ ಹೆಂಗೆ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ ನಾವು? ಸೀರೀಸಲ್ಲೇ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ಮತ್ತು RS ಇದೆ ಸರ್ ಪ್ಯಾರಲಲ್ ಮಾಡಿದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ದಿಸ್ ಇಸ್ ಶಂಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಅಂದರೆ ಗ್ಯಾಲೋನೋಮೀಟರ್ನ ವಿ ಹ್ಯಾವ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಅಮೀಟರ್ ಬೈ ಕನೆಕ್ಟಿಂಗ್ ಶಂಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇನ್ ಪ್ಯಾರಲಲ್. ದಿಸ್ ಹೋಲ್ ಅಸೆಂಬ್ಲಿ ಇಸ್ ನೌ ಎನ್ ಅಮೀಟರ್. ಏನು ಎಲ್ಲೋ ಬಾಕ್ಸಲ್ಲಿ ಹಾಕ್ತೀನಲ್ಲ ನೋಡಿ, ದಿಸ್ ಎಲ್ಲೋ ಬಾಕ್ಸ್. So this whole assembly is ಇದು ammeter. ಇವಾಗ this is ammeter. This ammeter is always connected in series. So when it is connected in series, it should not alter the original value of the current. ನೋಟ್ ಸ್ವಲ್ಪ ಬರ್ಕೊಂಡಿದ್ದೀರಾ? So it should not alter the original value of current, and its resistance should be very 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 less. If the resistance becomes zero, then it's called an ideal ammeter. So the next point is, what is an ideal voltmeter ಅಂದ್ರೆ ಏನು? So what is ideal voltmeter? An ideal voltmeter should have infinite resistance. ಎಂಥ ವೋಲ್ಟ್ಮೀಟರ್? ಐಡಿಯಲ್ ವೋಲ್ಟ್ಮೀಟರ್. ಎ ವೋಲ್ಟ್ಮೀಟರ್ನ ವೋಲ್ಟಾಮೀಟರ್, ನಾಟ್ ವೋಲ್ಟಾಮೀಟರ್, ಇಟ್ ಇಸ್ ವೋಲ್ಟ್ಮೀಟರ್. ಎನ್ ಐಡಿಯಲ್ ವೋಲ್ಟ್ಮೀಟರ್, ಫಾರ್ ಎನ್ ವೋಲ್ಟ್ಮೀಟರ್ ಟು ಬಿ ಐಡಿಯಲ್, ಇಟ್ಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಶುಡ್ ಬಿ ಇನ್ಫೈನೈಟ್. ಇರೋಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಇನ್ಫೈನೈಟ್ ಇದ್ದರೆ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ideal voltmeter. You know the circuit diagram for voltmeter. ಯಾವ ಥರ ಇರುತ್ತೆ? for circuit diagram for voltmeter, so there will be a galvanometer, there is Rg, there is galvanometer G, there is resistance of the galvanometer Rg. will connect a very high resistance in series. ಇಲ್ಲೊಂದು high resistance ನ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. this is R. now this assembly is a voltmeter. so ಇದು voltmeter ಐಡಿಯಲ್ ಆಗಬೇಕು ಅಂದರೆ its resistance should be infinite. You should remember. But infinite resistance ಆಗ ಸಾಧ್ಯ ಇಲ್ಲ. therefore no voltmeter is ideal. but ideal ಆಗಬೇಕು ಅಂದರೆ its resistance should be very 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 high. ಎಷ್ಟು ಅಂದರೆ it should be infinite. always voltmeter is connected in parallel. ನೆನಪಿರಲಿ, always voltmeter is connected in parallel. ಏನು ಈ ಸರ್ಕ್ಯೂಟ್ ಇದು ಬರ್ದಿನ ಬಾಕ್ಸ್ ಇದು, this is voltmeter that is always connected in parallel. so when it is connected in parallel, it should not alter the original potential difference. Ammeter should not alter the original current. The voltmeter should not alter the original potential difference. So in order not to alter the original potential difference, its resistance should be very very high. If it is ideal, then it is infinite. Infinite. Also we have derived another equation. So the important equation, so that is the into the angular deflection. What deflection? Angular deflection of a moving coil galvanometer, that is pi. This is the third point. So now I am going to make the third note. What was the equation? The angular deflection pi, that is equal to NAB by K into I. This is the equation that you know. So I will take this I to the LHS. It becomes pi by I will be equal to NAB by K. So this pi by I is called current sensitivity. This pi by I ಇದೆಯಲ್ಲ, this pi by I ಏನು? pi ಅಂದರೆ ಡಿಫ್ಲೆಕ್ಷನ್, I ಅಂದರೆ ಕರೆಂಟ್. ಸೊ ದಿಸ್ ಇಸ್ pi by I. this ratio is called ಎಂದು ಕರೀತಿದ್ದಕ್ಕೆ ಕರೆಂಟ್ ಸೆನ್ಸಿಟಿವಿಟಿ ಆಫ್ ದ ಗ್ಯಾಲೋನೋಮೀಟರ್. ಸೆನ್ಸಿಟಿವಿಟಿ ಆಫ್ ದ ಗ್ಯಾಲೋನೋಮೀಟರ್ ಅಂದರೆ ಒಂದು ಗ್ಯಾಲೋನೋಮೀಟರ್ ಭಾಳ ಒಳ್ಳೆ ಗ್ಯಾಲೋನೋಮೀಟರ್ ಆಗಿರಬೇಕು ಅಂದರೆ ಇಟ್ ಶುಡ್ ಹ್ಯಾವ್ ವೆರಿ ಹೈ ಕರೆಂಟ್ ಸೆನ್ಸಿಟಿವಿಟಿ. ಕೆಲವರು ಸ್ವಲ್ಪ ಮುಟ್ಟರು ಸಾಕು ಗೊತ್ತಾಗ್ಬಿಡ್ತಾರೆ ಯಾರು ಮುಟ್ತಿದ್ದಾರೆ ಅಂತ. ದಟ್ ಈಸ್ he or she is ವೆರಿ ಸೆನ್ಸಿಟಿವ್. ಕೆಲವರಿಗೆ ಒಂದು ಸೂಜಿ ತಂಡು ಚುಚ್ಚೂರು ಗೊತ್ತಾಗಲ್ಲ. ಅಂದರೆ he or she is not sensitive. ಹೆಂಗಿರಬೇಕು, you should be sensitive or not sensitive, you should be sensitive so that we can catch all the instincts. So in the same manner a galvanometer should be have very high current sensitivity, and pi by I value should be very high. So this pi by I is called current sensitivity of the galvanometer. How to ಕೇಳ್ತಾನೆ, how to define current sensitivity ಅಂತ. What is pi? Angular deflection per unit current. Angular deflection, that is pi. Angular deflection, that is pi per unit current, that is I. So that is called current sensitivity. How to define current sensitivity of a galvanometer? Angular deflection per unit current, that is called current sensitivity of a galvanometer. So you have a galvanometer. So this is the scale of the galvanometer. This scale irutte nodi diagram, moving coil galvanometer. So there will be a scale. So there will be a pointer. One pointer irutte. This is the pointer. So angular deflection per unit current. ನೀವು ಒಂದು ಯೂನಿಟ್ ಅಷ್ಟು ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡಿಬಿಡ್ತೀವಿ, ಯು ಪಾಸ್ ಎ ಯೂನಿಟ್ ಅಮೌಂಟ್ ಆಫ್ ಕರೆಂಟ್ ಟು ದ ಕಾಯಿಲ್. ಸೊ ಅವಾಗ ಅದು ಎಷ್ಟು ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸ್ತು? Say it show for 1 ampere of current, say it makes some 30 deflections. It shows 30 deflections. So therefore 30 by 1. This is called as current sensitivity. Current sensitivity. So the current sensitivity is number of divisions per ampere. So it can be written as number of divisions per ampere. Divisions per ampere. So for a good galvanometer, current sensitivity should be very high. So therefore what is current sensitivity? The angular deflection per unit current. ಇನ್ನೊಂದು galvanometer ಇದೆಯಪ್ಪ, ನೀನು 1 ಆಂಪಿಯರ್ ಅಷ್ಟು ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡಿ, ಇಟ್ ಶೋಸ್ 50 ಡಿಫ್ಲೆಕ್ಷನ್. ಆವಾಗ ಇಟ್ ಈಸ್ ಮೋರ್ ಸೆನ್ಸಿಟಿವ್. ಯಾಕಂದ್ರೆ ಬರೀ 1 ಆಂಪಿಯರ್ಗೆ ಮೊದಲು ಇಟ್ ವಾಸ್ ಶೋಯಿಂಗ್ 30 ಡಿಫ್ಲೆಕ್ಷನ್. ಇವಾಗ 1 ಆಂಪಿಯರ್ ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡಿ ಇಟ್ ಈಸ್ ಶೋಯಿಂಗ್ 50 ಡಿಫ್ಲೆಕ್ಷನ್. ಇಟ್ ಈಸ್ ಮೋರ್ ಸೆನ್ಸಿಟಿವ್. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ as ಕರೆಂಟ್ ಸೆನ್ಸಿಟಿವಿಟಿ. ಇಟ್ ಈಸ್ ಡಿಫೈನ್ಡ್ as ಡಿಫ್ಲೆಕ್ಷನ್ ಪರ್ ಯೂನಿಟ್ ಕರೆಂಟ್. We can also define voltage sensitivity. You can define what on the voltage sensitivity. So pi by I is called current sensitivity. Adhe tara pi by V andre deflection per unit voltage. Deflection per unit voltage is called voltage sensitivity. So from this equation we can come, so pi from not this equation, so we shall use the previous original equation use on from this equation. From this I'll divide both sides by V. Voltage is divided by pi by V will be equal to NAB by K. Again divide by pi. I divide by V. ಎರಡು ಕಡೆ V ಇಂದ ಡಿವೈಡ್ ಮಾಡಿ, voltage ಇಂದ. So this pi by V is called voltage sensitivity. So this pi by V is called voltage sensitivity. This is called voltage sensitivity. So that is equal to pi by V, that is voltage sensitivity. Pi by V is equal to NAB by K. What is I by V? V by is R. I by V is 1 by R. 1 by V is equal to IR. I by V. Now V this becomes 1 by R. So therefore voltage sensitivity will be called NAB by K into 1 by R. NAB by K into 1 by R. So what is voltage sensitivity? Angular deflection per unit voltage. That is called voltage sensitivity. Angular deflection per unit current is called current sensitivity. Then how to increase the current sensitivity? Current sensitivity, current sensitivity of this here. So how to increase this current sensitivity? So current sensitivity can be increased by increasing the number of turns. How to increase the current sensitivity? You should know this pi by I can be increased by increasing the number of turns. N value ಇದೆಲ್ಲ, ಆ n value ನ increase ಮಾಡಿದ್ರೆ we can increase the current sensitivity. So for example, if n ಇತ್ತು ಅಂತೇಳಿ, ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್ n ಇತ್ತು, ಅದನ್ನ 2n ಮಾಡಿಬಿಟ್ಟೆ ಅಂತೇಳಿ, ಡಬಲ್ ಮಾಡಿಬಿಟ್ಟೆ, ಅವೇನತ್ತೆ ಕರೆಂಟ್ ಸೆನ್ಸಿಟಿವಿಟಿ pi by I ಇತ್ತು n ಇದ್ದಾಗ. when the number of turns was n, the current sensitivity was pi by I. when number of turns is 2n, the current sensitivity becomes 2 times pi by I. pi by I ಅಂದರೆ the current sensitivity doubles. How to increase the current sensitivity of a galvanometer? By increasing the number of turns. If the number of turns is doubled, the current sensitivity is also doubled. If the number of turns is tripled, 3n ಮಾಡಿಬಿಟ್ರೆ the current sensitivity becomes 3 times. ಈ ಥರ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. But by increasing the number of turns, ನೋಡಿ ಇಲ್ಲಿ come to this equation. come to this equation. By increasing the number of turns ನೋಡಿ ಇಲ್ಲಿ ಈ from this equation, if you increase the number of turns, ನೀನು n ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ voltage sensitivity cannot be increased. Voltage sensitivity ಜಾಸ್ತಿ ಆಗಲ್ಲ, it remains constant. It remains constant. But ಇಲ್ಲಿ as the number of turns increases, the current sensitivity also increases, you should remember. But as the number of turns increases, the voltage sensitivity will not increase, it will remain constant. Okay, if you increase the number of turns, ನೋಡಿ ಜಾಸ್ತಿ ಸುತ್ತಿರ್ತೀಯಪ್ಪ, ಇಫ್ ಯು ದ ಟರ್ನ್ಸ್ ಕಾಯಿಲಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್ ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋದರೆ ದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಲ್ಸೋ ಇನ್ಕ್ರೀಸ್. ನೋಡಿ ಇಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಟರ್ಮ್ ಇದೆ, ಬಟ್ ಇಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅನ್ನೋ ಟರ್ಮೇ ಇರಲಿಲ್ಲ. ಆದ ಕಾರಣ ಆ್ಯಸ್ ಎನ್ ಇನ್ಕ್ರೀಸಸ್ ಕರೆಂಟ್ ಸೆನ್ಸಿಟಿವಿಟಿ ಅದು ಆಲ್ಸೋ ಇನ್ಕ್ರೀಸಿಂಗ್. ಬಟ್ ಯು ಸಿ ಅಬ್ಸರ್ವ್ ದಿಸ್ ಇಕ್ವೇಷನ್ ಕೇರ್ಫುಲಿ. ಆ್ಯಸ್ ಎನ್ ಇನ್ಕ್ರೀಸಸ್ ದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಲ್ಸೋ ಇನ್ಕ್ರೀಸಸ್, ಬಿಕಾಸ್ resistance depends directly on the length of the wire. R is proportional to L. R is equal to rho L by A. So you know this equation. Although R is proportional to L. As number of turns increases, length also increases. As length increases, resistance also increases. So as N increases, resistance also increases. So that ಎರಡು neutralize ಆಗಿ, so both will cancel. Therefore the voltage sensitivity remains same. ಹೌದಾನೆ? For example, if n becomes double, n ಇದ್ದಿದ್ದು 2n ಆಯಿತು ಅಂತ ಹೇಳಿ. if n becomes 2n, if n becomes 2n pi by v, ಹೌದಾನೆ? ಸೊ if n becomes 2n, r becomes 2r. ನೋಡಿ n ಇದ್ದಿದ್ದು ಡಬಲ್ ಆಯಿತು ಅಂದರೆ, n ಡಬಲ್ ಆಯಿತು ಅಂದರೆ r ಡಬಲ್ ಆಗ್ಬಿಡುತ್ತೆ. ಸೊ ಅವಾಗ ಇಲ್ಲಿ ದಿಸ್ ಬಿಕಮ್ಸ್ 2n, ಸೊ ದಿಸ್ ಬಿಕಮ್ಸ್ but this becomes 2n, this becomes 2r, so 2 and 2 gets cancelled, again same thing remains. Andre as n increases, the voltage sensitivity pi by v remains constant, it will not change. So this is about voltage sensitivity and current sensitivity, and you should know the definition and equation. What is the SI unit for voltage sensitivity? Just remember pi by v and divisions per voltage. What is the SI unit for current sensitivity? Divisions per ampere. So this is about the voltage sensitivity and current sensitivity of a galvanometer, and this is the end of the chapter number 4. From next video we shall solve more and more problems related to this chapter. Read the notes, I will send the assignment, you write the answer for all the questions that are given in the assignment. I will give you some 3 or 4 days, so read the notes carefully. From tomorrow we shall go for the problems.